Okay, so I think we can start. That's fine. Sometimes they will just jump in
Okay.
during the talk. So today I'm very happy to invite our the professor in our school. So Professor Ricky Lee. He's from the Automation Graduate Institute in our school. So he's also a member of Robotic Center in Town Tech, and he's famous for building various kinds of robots, mobile robots, which flies, moving on the ground, and also in the water.
Yes.
Yeah. So he has been working on AI implemented in various kinds of robots. So in his presentation today, he's going to talk about AI for robotics. So I will give the time to Professor Lee. So
Thank you.
let's welcome Professor Lee.
Thank you, Professor Ling. Good morning, everyone. And today I would like to talk about applying AI, okay, in robotic. Basically, I would like to share our experience, and so not really like down to the details technique. So there's a three intelligence. Okay, basically we are applying. Well, suddenly, okay. Well, first I would like to introduce myself, and I got my bachelor degree from Taiwan, and then I went to Cornell and United States, and for my master and the PhD. So you may wondering why I suddenly from manufacturing to robotics. I changed the departments to agriculture and biological engineering because at that time my advisor he changed his topic, so I left no choice. If I still want to do AI for robotics, I have to change department. So my PhD dissertation is applying AI in the robot pruning, agricultural robot for pruning the grape. That's my education, and then after that I went to Canada because I live in Canada and work in the university as a research scientist, and then I went to government as a research officer, and then back to Taiwan. Okay, so this is my contact and my line, my Facebook and WeChat. So basically that's me. So quickly to introduce myself. Okay, first AI and robotics actually, I assume everyone is a graduate students, right? So most of the people, when they searching for thesis, they are thinking, oh, what kind of topic I want to do, right? So usually people starting with technique. Oh, I want to do deep learning, I want to do UAV, I want to do RNN, all those kind of things. So, but I think you should start with creativity. Anyone can tell me what is the difference between innovation and creativity? 创新与创意 Innovation and creativity. Anyone? Huh? Guessing, lucky guess. Okay, how about you? Just guess. Interactive, innovative, right? And creative. 创新, 创意. So what is the difference? You think? Do you want to guess? Okay. The difference as innovation equal to creativity plus action. So if you are the master students, actually that's a thesis. Thesis actually should be 50% talking about the creativity, 50% talking about the action. So if you only have a creativity, okay, you cannot call it an innovation because it's not being implemented, it's not being verified, okay? But if you only have an action, no creativity, so then it means there's no value. So in this case, usually I guide my students start with creativity, creativity, 由创意开始 and action is just improving it. So it's like a concept generation and proof of a concept. 概念呈现，概念验证。So 50% creativity is about the introduction, method. This is the result and discussion. So introduction, talking about what is the problem, why is the problem important, and what are you challenging or extending, what's your solution. Method, talk about your approach, okay, but not done anything yet about your idea, about the hypothesis, what hypothesis you made, and what's the problem statement, what is the related work, those things like marketing. So in this case, I call it a proposal. So when I told my students, I said 50% is this, 50% is this, okay, and start with this. How do we start creativity? How? How do we start creativity? Huh? Thinking. Well, that's very general. So if you just keep thinking, do you think you can get somewhere? Okay, for example, if AI for robotic, creativity. No, how you thinking and what? Researching. Researching of what? The past research work. Past research work. Okay? In general, it's okay, past research work. But I usually think the concept of research start with simple. Not, I mean, past research work. That's, yeah, that should be, but not at this stage. It's just like a starting point. Okay? Oh, you study some paper. You have to understand it first. Then you will find, oh, this is so difficult. What can I do? And oh, those research, okay, deep learning, robot, okay, reinforcement learning. Oh, man, what should I do? It's not creativity. It's more actually you are challenging yourself. To my opinion, we are the people in here, action. You study all the technique. You are not the people doing creativity. You're not being trained for creativity. You're being trained for action, right? Writing program, simulation, did the mechanism, circuit, those kind of things. You're not being trained for creativity. Who being trained for creativity? Movie maker, okay? Movie maker. Scientific friction, okay? Actually, I started with my career by through this way, and actually I generate a lot of paper through this way. I watch a movie, scientific fiction, and say, oh yeah, we can make this come true. And then we seeking for technical solution. So it can be AI or not AI, either way. But a lot of people, they doing different way. They start with, okay, I'm going to do AI, so I was just doing the AI. And then, oh, I want to do deep learning. Okay, then I created a problem that deep learning can solve it. No, I think it should be the other way. The other way. You create a problem first. This problem is like the very, very original concept. So I provide several things for that you can doing your creativity. One is called attribute spectrum. So there is a one, it's like a block. It's like a block. I'm not going to link into it. You just have an RGB spectrum and you're choosing from here. They have several blocks, say artificial intelligence and robotic. Well, you say, oh, professor, you told me not not start with the technique. Yes, because that one you will not see any, you wouldn't see any technique. You only see story and video. So, for example, I'll just click the one and showing you. So let's say I'm going to attribute robotics. Okay, well, then and the art and Apple engineering. So that's what I'm saying. I mean here, there is those technical areas actually defined. So in here, not only academic, but also company like Apple, NASA, they present a concept generation work. So that means not completed yet. Sometimes they just make it and some abstract video. So in this case, it's a very starting idea. So that's one thing, and you don't need to say, oh, I need to study math and to understand it. So for example, let's see, they all have this video. And the primary is here. Okay, so well, we go into robotics, and they have all those story, and read the. Say for example, I just click anything. Okay, if robot photographer takes the perfect picture, and you wouldn't see, you're not going to see any formula. Okay, you only see all those words, which is the story about their concept. They even have a video. So that means if you don't really, well, I think it's the delay. So you don't need to really learn math, physics. You can understand. They have a photo, they have a video, they describe their work. So why people post their work in here, not in academic? If you publish in a journal, those research article, how many people will go really read the paper? Yeah, because you need to have a certain knowledge already, then you can read it, right? For those journal paper, conference paper, if you doesn't study that area, you have no idea to read that paper. But this one is for even banker. So some banking, a lot of banking and the investor people, they read this site every day. Why? Looking for investment opportunity. Some company, their business marketing people, they read it. Oh, yeah, because this is a lot like a small new startup company, 新创公司. So their work they post on here. So they will see, oh, this company is good. Yeah, let's go talk to them. Maybe we merge them because they are starting up. So there's a lot of companies work here, a lot of university labs work, a lot of like government agencies work. So I encourage you, go to look at this site, and it's just like科普, right? And it's like in general, okay. In general, story about their work in very simple format. So that means you don't need to learn deep learning, but you say, okay, how about if I really want to, I'm interested in this, so I deeply go into it, they have their link. So that's why it's very difficult, your work to post in this, because high visibility. because people can see your work, not only academically, but the company. So one resource searching from here, because what I mean by creativity, when you're thinking, you need to already read a lot, right? But not technically, more like in subject, more in like subject, oh, there's people doing the thing, there's people doing the thing. Starting with that, it's much, much easier. Okay, second, as I say, watch a movie, scientific movie. Actually, a lot of work coming out from making the scientific movies things true. Yeah, like a Terminator. If you see a lot of my work, I mean, my idea coming from there. At that time, it's just a friction. I just make it work. So, not necessarily have to be AI or non-AI, right? So all those movie, if you really watch it, I mean, there's a lot of scientific movies, but if you go to it, you will see, oh yeah, maybe I can doing this. So that's why I always ask my students, you told me this story to me first, okay? And third, well, if you want to do my area, we have some past work. Basically, I posted in my Facebook. I use my Facebook as an official website because at that time, my time doesn't have a website. So I just using Facebook. So even you didn't add me as a friend, you still can see it. You're going to album, you're going to my Facebook. So my each paper's work, I even put a video there. Okay, so you say, oh, how about I just search your paper. Yes, you can find it, but the thing is, there's no video, right? So I put more details around when we publish it. So that's my Facebook. I think you just type ricky.mf.lee, or if you search my name, and in Chinese, Li Mingfan, okay, and I think you can find me as well, or Ricky dot mf dot lee, okay, dot lee. So that's my FB, and if you search it, I think you can find it. Well, that's how I told my students, start with some people's work in general, in all different kind of. If you go to the site, you will find that there's a lot, even not started yet. It's crazy. It's a crazy idea. It's a thinking. They are thinking, oh, well, can we do this? Can we do this? Sometimes it's like that. Or they already make some small prototype. Okay, so that's something for creativity. So don't start with technique because it may kill you. And second, do you really have that passion? Yeah, so for example, ask you to read reinforcement learning. Well, I think after a couple pages, you'll say, oh, this is boring. Yeah, why? Because you don't have an object. Why do you learn this? Yeah, deep learning, okay. Why? Oh, because it's popular. It's not a passion, right? But the passion is, oh, I'm going to solve things. Well, I'm going to make that Terminator things work. Well, then that's a different story. Then you go back to see, oh, if I apply reinforcement learning, can we make that happen? Well, then that's different. Your passion is different. So don't be ashamed because you are not doing creativity person. You are doing action people. So as I say, borrowing the other people's creativity, seeing the other people, especially those are, all those are fiction. There's no copyrighted things, right? Because you make it work. And you can even refer to that movie. Well, I make that movie, the scenario become true. Wow, Steven Spielberg, wow, that's a big job, right? You make some scientific more movies a part of this one work. Well, that's very stunning. Intelligent and smart. So we talk about the AI, artificial intelligence. What is the difference between intelligent and smart? What is the Chinese name for intelligence? Intelligent. 中文。智慧 ，smart。聪明 ，OK。聪明跟智慧有何不同 ？Intelligent and smart. See, what is this? This is what is the English? Smartphone. Smartphone, right? Why didn't call intelligent phone? 那智慧手机嘛，那你刚刚讲 intelligent 是智慧 ，why call English? So why call it a smartphone, not intelligent phone? And IQ, which is your intelligence level, so intelligent quotient, IQ. So why didn't call smart quotient? That means there's some difference, right? So think about it, smartphone, smart and difference. So basically, intelligence is by biologists defined humans' way to do things, capability, your human animal or human's capability doesn't mean it function well. So for example, we are human, we still making mistake, but our way doesn't mean it's work, but smart means work. By all means, as long as it can work. So that's why you call smartphone, not an intelligent phone. If intelligent phone, then you have using AI way, then yours is intelligent phone. That means you're doing human, animals way. So we have a three intelligence: inference intelligence, learning intelligence, and evolution intelligence. So how human doing those three things? That means your intelligence. So we want to know if there's an alien, if this dog have a higher intelligence level, or cat have more, or human have more, or if we define the alien. So we're using this way to define the humans, animal, mammal, or even fish. Okay, what's your level? So when you're doing the test, it's a testing capability of this. Well, that's all. Artificial intelligence is a machine imitate human intelligence. That means how human doing things. Well, remember one thing. Artificial intelligence, a lot of people think it will work. It's a function. It's definitely solve every problem. No, it's just a different way to do things. Smart is by all means. So for example, you can be a smart person, but you even cannot calculate math, can you? Do you know there's a lot of people, they are very smart, and they are in the jail, okay? They're already in the jail. They are very smart. They cannot even do 1 + 1 = 2, but they can make money. Sometimes it's not very in good way, okay? Or they can solve issues. For example, you owe me some money. I want to collect the money from you. Okay, yeah, I'm talking about the law, talking about the thing. Yeah, you just doesn't give me back the money, right? But some people, they have their way. Okay, they bring a basketball, the baseball bat, okay, and come here to talk. Okay, please return me the money. So smart, he's smart, but it works. He get the money back, but doesn't mean right away. A good way could be a negative way, as long as it works. So intelligence basically is talk about how human do it. So we put it into an engineering problem, those three intelligence. Because most of the people thinking right now is learning, like a machine learning, deep learning. I have a block here, okay, model, input, model, output. So first, the inference intelligence, solving simulation problem. Simulation problem. Now, I just say this is the human's way. We have an input, we have a model, and we inference our output, right? So for example, like driving, this input the distance, input the sensor distance, how far the obstacle from me, how far the goal from me, okay, to input. Oh, my model is a rule. Oh, if the distance is too far or the to go to obstacle, so I reduce my velocity. So that's the inference simulation problem. Why? Because you through the input and the model. If you want to design two circuits, right? Okay, I design two circuits. Which one is good? I through simulation first. Of course, you can make it, you can fabricate it. But if you fabricate it, it wastes money, right? Because one doesn't work. So in this case, I simulate it first. Oh, I have some model, and I can simulate the result. So I have the two design of the circuit. So then I get the output. So similar simulation, inference intelligence, which you have two is known, and you're looking for your output. Second, intelligence, learning intelligence, modeling problem. You know your input, output, and you find their relation. So, for example, buying stocks. Oh, you have today's trading price. You have today's trading volume, and your output is sell or buy. Oh, every day, daily history. Then you're finding out their relation. So when you have a new data, oh, today I should buy the market. So this is modeling. That means you have an input out. So that's why we call big data, right? Because we have data. So then we find the model. So modeling problem, and corresponding to learning intelligence. So there is a lot of non-AI way to do modeling, and this is the AI way. So machine learning, this one like a fuzzy logic. Third, now only two known, looking for one known. Now only third option, which is this two known, and looking for input. So based on some requirement, which input can get my best performance, optimization. So evolution. That's because animal or human, they improve. It's because evolution, right? Generation, better and better. All can do the same thing. For example, in my generation, your generation, we all can make the work happen. Yeah, but the next generation becomes a better way, more efficient way. For example, the young people generation, you are very good in using the smartphone. Like all my students, much better than me, so they can search the data information much faster than I do. They know all the different apps, all those things. Well, so evolution. And animal also, the survival of the fittest. Okay, so in this way, we're using this like an optimization problem and evolution intelligence, genetic algorithm. Okay, that's the technical work. So don't be confused by current news. They are all talking about it. It's this part only, not this two. Anyone know why? Money, business, because data. You want to calculate the big data. First, you need to have a storage to store the data, right? Because if it's 1 year's data, if it's a video, I think it's 100 TB or 1,000 TB data to store 1 year video, or cloud. So those company can make money for storing your data. Cloud company, Google. Second, you want to calculate this amount of data's relation. You need a computation power. Wow, GPU, semiconductor, so they can make money, For those two, they don't have, because it's not using big data. So in this way, doesn't really that benefit so many storage and data, okay? Well, autonomous and automatic. So a lot of people, what is the difference? Well, now we are talking about what is the AI doing. Automatic. Autonomous is automatic plus to deal with uncertainty. So how to deal with this uncertainty, AI or non-AI approach. So automatic, let's just say, a robot, I just go here 50 times. Okay, my robot following. That's automatic. But if suddenly there's an obstacle in here, can I avoid or not? I didn't know in advance. If I hit it, well, I'm only automatic because I only follow pre-programmed task. So all this research, AI or non-AI, is trying to deal with uncertainty. So even for example, we're doing Face ID, uncertainty, light changing, right? Or view angle. I want to Face ID hit her, but I was taking from this side. Well, I cannot recognize uncertainty. That means these things cannot be predicted, cannot be pre-programmed. So that's why a lot of company, they stay with automatic, maybe 90% automatically. So they still 10% with the human. So if you want 100% deal with this uncertainty, you becomes autonomous mode, okay? So what is the difference between mobile robot and a manned vehicle? Both are moving. Is that just a different name? Well, right? Even you translate to Chinese, it's a different name. It's a different name. Concept-wise, it's different. Control mode. So there's 3 control modes: teleoperated, wireless control, automatically, as I say, okay, 50 times, okay, cannot deal with uncertainty, automatic. Autonomous, you have to be handle uncertainty. Doesn't matter be 100%, but you did some part, you can handle uncertainty, so then you become autonomous. So anything moving, you can call, without a human in there, a manned vehicle. It can be 3 mode. Each mode, you can all call a manned vehicle, but a mobile robot have to be autonomous. That's the research area, which is autonomy. For a manned vehicle, all 3 modes, as long as no human are in there, your wireless control, remote control, automatic mode, you can all call it a manned vehicle. So in this case, where does it move? It's in the middle. So for example, if this things UAV, this is moving in the air, we call unmanned aerial vehicle. For mobile robot, it's in the beginning, aerial mobile robot, surface mobile robot, underwater mobile robot, or a manned underwater vehicle. A lot of people may think, well, now in this case, if I want to do easier research, well, how about I choosing a manned vehicle? Wow, a manned vehicle looks like easier. All 3, you can call it a manned vehicle. Well, this is why I have to be autonomy. You have no choice. Wow, it must be difficult. No, totally not. Because a manned vehicle's focus is on first, how long you can travel. Can your manned vehicle travel 20 hours? Energy, power, okay? And how far, how long, and how far, including if UAV used fly in the 10,000 meter and 20 kilometer. Well, you think that's easy? Yeah, you can teleoperate it. You can just remote it. But the 10,000 meter or 20,000 meter in the height and moving 20 hours and 500 kilometer, you still can control it. Well, I don't think it's easy, right? Autonomous, you can be low altitude. So an UAV, can avoid something. Yeah, then that's become autonomous. So which one you think is easier? Well, there's no easy or difficult depending on you like it or not. If you like it, wow, that's easy. If you don't like it, you don't have a passion, well, that becomes difficult. So that's my thinking. So, well, for time being, I want to quickly, so that's Industrial 3.0's focus, automatic. 4.0 is about autonomous. 10 minutes. Okay, so the ability cost down, so my price can down, so I be competitive. 4.0, basically you're adding AI, it's more expensive, but my value is up because I reduce the human, I reduce some cheap labor. So in this case, well, more environmental, okay? But my cost is higher, so my price will be even more expensive. Okay, I will not spend too much time here. So now I want to go talk to my lab's work. So basically, according to my definition, we using artificial intelligence making a manned vehicle into an autonomous mobile robot. So that's what I say, the difference between mobile robot, between automatic and autonomous. So I applied AI to solve uncertainty, make those unmanned vehicle into autonomous mobile robot. So my lab is T1204. If after all you are interested, welcome to visit my lab. So 3 intelligence and 4 locomotion plus together, so artificial applying the unmanned vehicle into autonomous mobile robot. So this is a part of our locomotion. Well, you are in this university, my lab is in the T1204, you can come to visit me. And so we are commanding the 4 things. This is my structure. So basically cloud and edge. So this is a cloud and this is the edge on device. So cloud AI, edge AI, and on device the AI. So cloud and edge. Well, and because of time concern, I will go to some of our case. And so first, ground mobile robot shooting. So there is a gun here. And so this is the human. So first, recognize your pose. If I say this is today's password. You don't need to say it. Okay, so he recognize, okay, you are the master. You are a good guy. I'm not going to kill you. So he recognized him. He just following him. But he's still aiming. Here. The gun is there, and there's a trigger. And later, you will find another person coming. He didn't have this. Well, because the sound, they asked me to turn it off. You will see a big sound, shooting. So this one was shooting. Currently, we're mounting we have even better shooting mechanism now in our boat and in the UAV. So we want to do the joint shooting. All right. So this is the ground. And second, like a COVID-19. And so this is to do low-level control, high-level control. And this one is recognize your temperature. Do you wear a mask? And have you been quarantined? And this is our university library. So at that time, COVID-19. Okay. And so now to in the aerial, I just introduced some of the case. And for face recognition, so UAV fly looking for bad guys, So for example, okay, I find him, I lock him, okay, moving your head. Go. So I keep moving. I track him like a missile. Okay, and so the aerial, and also this is like a pose recognition, and there will be a UAV, there will be UAV fly, and doing your pose. So now you are standing, and you are stretching. So is this okay? Stretch. This one is okay. Do you think it's a safe or not a safe action? Violent or not violent? Violent or not violent? This one. It's good, right? It's okay. It's okay, right? It's okay. So I still same. Still okay? 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 Oh, still okay? Not okay, but so in this case we using fuzzy. There's action is okay, but with combined with the other object, it becomes not okay. So we are interpreting those behavior. Those behavior could be okay or could not be okay. You are just exercising, or you are trying to punch someone. Okay, so this is our service robot. So service robot, and we made it by ourselves, and we put a sonar, laser, camera, IMU in there, and we put an airport there for our UAV landing. And you can see this in my lab. And so that's why it's also we made another boat in Turtle Pond, tracking another boat, And so, for example, if this boat is like an enemy's boat, or they are smuggling, so we can find him, and tracking means we keep knowing your position and we following. So both boat we DIY'd, and now underwater, so submarine, okay. And so this one we are testing and measuring the range obstacle. So we're using a laser and a camera to detect the distance. And so this one, we are into the real ocean in Taiwan. So we go deep down to measuring, to search for fish, for a particular fish. Augmented reality, we're generating the data for training to looking for a particular fish underwater. Okay, and also we have an underwater robot to tracking another underwater robot. So this is all in our turtle pond. So you can see we keep tracking this. But if you've been to our turtle pond, you will see there's a lot of turtle in there. So turtle will block all things, but we still can track it. Look, because we're guessing, oh, still here, and then we still can track it. All right, we're not completely losing the track. So now that's just single locomotion. So now we are combined joint operation. So robot collaboration. So this is ground and aerial. So this one, they will find target first. After he find the target, then he lead the robot. So basically that's there is a media coming to interview our lab. So we are doing joint things. So the robot come here to check what is inside. So UAV find the target first. Okay, then robot go. So we build a map, a path. So robot go there. So that's me at that time. And this is our UAV. And that's a very early time, the media interview. And then next, ground and aerial. So we're using UAV to building the map because you're higher, you'll see more. So building the path, and then ground aerial. So this one is for landing, and this is our university swimming pool. So you can see the robot landed on the ground, mobile robot. So we recognize the age, so he search and control his position and landed landed. And service means the ship. So both are moving at that time. So it's more challenging and challenging because the one is keep moving and unpredictable, uncertainty. So he have to keep searching, keep flying, and lower a little bit, and lower a little bit, and lower a little bit, and then drop. Okay. So you can see he find us and then landed them. And service aerial. So that means we want to join operation. So we have to know where is our boat. So in this case, this is our UAV, identify this boat is ours or not. And also building a map for him come to here. Because he cannot see everything. But in the air, you see everything. You see everything. But on here, locally, you only can part of the view. Your view is limited. So we're using this to build a map for him to navigate. That means we have our own satellite things. And also surface and underwater. So those things are both moving. Well, but you cannot have a different, you needed to have a pattern, right? If I'm moving this way, then no, because we attach a line in there. It's kind of like underwater ice. So they have a pattern because it's a different velocity file, different friction in air. So this one is S and this one is 1, but they have to maintain this pattern, team formation. And ground aerial service, so now complete the whole scenario. This UAV will taking off from our ship, and this ship cannot be flipped over. So when he flied up, basically he already know this position, and then guide him to here, and then he did it. So we have 4 robots to coordinate this motion, and he landed on the stationary. Then finally, and last one is all four vehicle robot. So there is a ship and there's a submarine under. They are looking for a safety pass because there's rock here. He cannot see the rock underwater, but the underwater submarine cannot see this. So they both working together and finding a most empty place. Then they travel. And this is the ground mobile robot, and this is the aerial. So until he into his sensing range, he will command this robot to taking off and fly and landed. So this one they are looking for empty, most empty place. So with underwater together, say, oh, this is all the rock, far away, keep away from them. Okay, so then they will find a safety pass. Come here. Once into this sensing zone, he will taking off. So you can see he's towards to here. So now they finding this one is the most empty. So the boat and the underwater submarine, they will go through. And once into the sensing range of this, okay, then you can see it's UAV taking off, warming up, taking off. So there is an airport. He will come back to take off as well. But he didn't know where is the ship, so he let him know. Guide him into here, the control, giving back to him, and he landed. Yeah, that's the technical scenario, and basically, when I come out of the scenario, Terminator. Yeah, if you go watch Terminator, I'm trying to make it those kind of simulator, all those different robot coordinated motion things to make the work. Yeah. Okay, that's will conclude my talk.
Okay, thank you, Professor Lee. So does any students has any questions?
Question? Yes. Wi-Fi. Yes, they are using Wi-Fi. So we basically, this technology called swarm intelligence. We're using Wi-Fi, but there's a problem. Wi-Fi is not very stable. Sometimes it interrupted. Well, however, as I said, you may say, oh yeah, this is why it's the problem, but this is not the problem we're trying to solve. Because we are trying to solve is he can be autonomous for communication. Well, if you give me a military communication, sure, I'm doing the same thing. A lot of people say, oh, this one robot is so small. How does it work? How does it go to? How does it go very far? No, you give me a real submarine. You give me a real UAV, airplane. You give me a tank. I was doing the same thing. Well, communication. You give me a good communication, then because I'm processing those information only. So Wi-Fi is really a big problem to us. We of course want to improve it, so we're thinking about it to using those kind of SIM card. But however, all our students, including myself, I'm not a communication major, so I'm not very good in communication. Those are communication, like a wireless communication. So that's really sometimes make all things totally no communication. Then, so that's why we develop a cloud edge AI. Once you don't have communication, depending on on-device AI. So we training on-device model. Once communication gone, you independently make your own decision. Yeah.
Okay, so yeah, go ahead.
Yes.
How is the robots recognize that the other robots friendly or not?
Oh yes, that's good. So training. So basically, all robot, we go through deep learning to train it, like a Face ID. So we recognize it's ours. So for example, we did a work for UAV to recognize the UAV. So when UAV flying, there's could be enemy's UAV, could be ours. So we only train ours. But for enemy one, once coming, we know it's an enemy. So then we update. So those data we call it the new data. The new data, this model cannot recognize. So for example, I know you, okay, but I didn't know him. So he is a UAV. Oh, I take his photo. I come in and I go into the cloud, and now into our model say, well, he's enemy one, enemy two, enemy and three. But we training the local model first is only on ours. Yes.
Okay, because of time, I think we need to finish. Okay, thank you today.
And welcome to my lab. Okay, and experience the shooting things. We can allow the robot to shoot you. Okay, feel it being hit by Terminator. Okay.